Hi, everybody. Well, it's a pleasure to be here with you today. I'm Andrew Geip-Lazaro, and this is Luis Barunda Monsivais, and we're professors in the School of Architecture. I'm going to be speaking on behalf of the NAVIGAID research team, which is currently developing assistive technology for the vision impaired. More specifically, we're conducting university and state-funded research to develop a mobile phone application which will provide improved AI-based descriptions, navigation, and alerts to vision-impaired individuals. After extensive market research and product development, we are currently testing a prototype of this application, which is the basis for some of my observations about the industry's potential and limitations today. And not listed here in our project team are Abhijit Sakar, who's working for us as a consultant. He's at VTTI, and two research assistants, undergraduate students from the School of Architecture, Tamia Barnes and Aaron Harrigan. I'm going to give a very abbreviated overview of the principal challenges faced by vision-impaired individuals, existing strategies for addressing these challenges, and opportunities for some more creative solutions. But before I do that, I want to mention some relevant facts. So as of the last survey data, 32 million people 18 and older reported experiencing vision loss in the United States. That's about 10% of the national population. Virginia is home to about 185,000 of these, about half of whom are unemployed. The total national economic burden of vision loss and blindness, according to the CDC, which is due specifically to reduced labor force participation, is estimated to be $16.2 billion annually. And finally, it's important to mention that somewhere between 10 and 15% of individuals with vision impairment are completely blind. The remainder have varying types and degrees of vision impairment, which may include a limited field of vision, some loss of central vision, gross short-sightedness, uncontrollable oscillations of the eyeball, and so on. With this variety of perspectives comes a variety of sensory means for interacting with the built environment. So individuals with vision impairment are always in touch with the surface of the ground, whether that's the texture of paving or raised tracks underfoot, or some other guiding feature that interacts with the cane in a haptic way. They may have a guide dog for a more direct kind of tactile input, or else use tactile signage or spatial qualities like the feeling of direct sunlight to help orient themselves. In terms of sound, always in touch with, let's say, in a meaningful way with the directionality of sound, its magnitude. And I'm remembering a story from a colleague of mine from DBVI, a blind colleague, who chooses a particular hotel whenever he visits travels to a distant city because it has a fountain in the lobby that helps him orient himself in the space by the sound of the water running. Keeping in mind that only 10 to 15% of individuals with vision impairment are totally blind, vision is still a very important part of this equation, let's say. Objects or surfaces with high contrast, signage with large print, remembering that the majority of these individuals can partially see. And I don't have smell or taste on this list, but these can also play an important role, like a lovely French participant I had in one of my blind accessible tour programs in central Italy, who could navigate to the bakery each morning just from the smell of the fresh bread. There are two meaningful spatial challenges encountered by individuals with vision impairment, we could say. The first is navigation, getting to and from a place, and the second is orientation, or becoming familiar with the space itself. An excellent, and I think we could even say the prototypical example of an interior workspace designed for multisensory comprehension is the main office of the San Francisco Lighthouse for the Blind and Visually Impaired. The space was designed by Mark Cavagnero Associates with consultation from a friend and collaborator of mine and of our research group, Chris Downey, blind architect and the Lighthouse's former president. He's going to be speaking about this and other projects when he visits the Virginia Tech School of Architecture this spring, April 4th, 2 p.m. in Hancock Hall. That should be very exciting. The space takes a deliberate approach to the separation of surfaces by using visual, acoustic, and tactile barriers. And I'm here referring to the separation of different floor surfaces using tactile strips and variation of lighting between corridors and gathering spaces, keeping in mind that this language of lighting is consistent across all 3 floors of the project. Ease of use is integrated into the perimeter stairwell, which I will parenthetically mention gets at one of the aspirations for accessible design, that it should be broadly beneficial and not only for a single constituency of disability. The spirit of this aspiration is present in the handrail design, which is meant to allow for uninterrupted support, important for maintaining balance and concentration while holding, among other things, a cane, and in the design of the stairs, which include reflective, tactile, and contrasting edges, together with tapered risers. We brought, for the annual blind design workshop, we brought blind young people, vision-impaired young people, to this space, and they had trouble with that stair. It was easy to identify as a landmark, and we just confirmed that ChatGPT 4V doesn't have a problem figuring out that it's a stair. But it wasn't easy to navigate, and the reason was that it has open risers. And so one of the typical ways that you use a cane to go up and down the stairs is to tap the riser as you walk, and the gap made it a bit confusing. Another more analog way of navigating the stair is sort of ramming your foot in so you can get a sense for where the stair ends. That was also a bit challenging. So I'm going to wrap up my portion of this presentation with 3 closing thoughts on the topic of disability and design, after which Louis will elaborate on points more specific to our project. First, architecture plays an essential role in the integration of AI into inclusive design technologies. The architecture of the software itself, so that, for example, audio descriptions of space which are generated by a mobile phone application are themselves carefully structured so as to substantiate an effective mental image of what's being described. We've been training our own mobile application to learn from the methods used by professional audio describers to acoustically manifest space. Second, the relationship of built spaces and AI is also essential, so that, for example, more legible built spaces with larger print signage, boundaries of higher contrast, etc., are also more legible for AI, for emerging approaches to object detection, depth estimation, and more broadly to computer vision. And lastly, I would charge ourselves, especially designers, to go beyond providing functional solutions, so seeing disability exclusively as a design problem, providing not only accommodation, but creative expression or elaboration. And I'll end with one of my favorite examples of this. These are notches in the welcome counter at the Lighthouse for the Blind, which hold your cane in place so that you can use 2 hands to interact with the receptionist. Sort of wonderful, beautiful little detail in that project.
Thanks, Andrew. And thanks, everyone, for joining us. I'd like to continue to speak more about the app itself, but with this slide on our back, I wanted to highlight that some discussions that we've been having over these months of nothing beats good design, right? But look at us, our team. It's also looking at the problem from different perspectives. It's a very polyhedral problem where we have the Virginia Tech Transportation Institute, Abhijit, on a consultation team, computer sciences, Nameng and Rishit Ganman working with us at the School of Architecture. So this raises a concern of how we look at space from different perspectives to solve the problems together. If we would say, for example, can we sense this space more efficiently, make it more accessible? If we look at it from the perspectives of maybe the Transportation Institute alone or the Computer Sciences Department alone, we would be facing a much larger, more complex problem. There's an interesting outcome of our collaboration that some problems are just simply easier to solve when in terms of architecture, some are simpler to solve in terms of computer sciences. So this is an invitation to look at, and a provocation to look at our environment in a different way, where we start to break it down into sensible moments, things that computers can understand, individuals can understand, and we can work together with machines in an interaction. So the challenge that we are facing first as NAVIGAID team is, let me see my time, that what is a machine learning problem? What part of the problem can you identify as something that the computer can actually help you to and assist you? We've identified that machine learning problems involve features that cannot be stochastic, so that cannot be a problem that has a random outcome. It has to be predictable, whatever you're trying to assist with AI. That's the first, subset of machine learning problems. Of course, the problems have to be logical, so it has to be a computer science problem. And the second consideration is that there has to be enough data, meaningful data, to be able to collect that and train the models to make it, let's say, precise and capable of solving the non-stochastic problem. So the invitation with NAVIGAID, the provocation, is to start looking at that environment and try to make sense of our meaningful data, but to connect us in communities, architectural design, innovation, through the machine learning, a technology that can bring us together, a technology that can help us build more resilient, more accessible, more inclusive spaces and communities. We developed NAVIGAID collaborating with different stakeholders, from distributors, public institutions, low vision individuals and blind individuals that can have helped us develop what kinds of features are needed, what kinds of elements are preferred to learn about the space. And we found with great excitement a tremendous challenge ahead of us, but also wonderful opportunities. So we presented the problem, and now we're presenting a perspective of how we are addressing this problem. The first time that we showed this app some days ago to two blind individuals, they mentioned, well, just the fact that they can hear more about a space was tremendously meaningful for them. The technology starts to help them understand more, have a more in-depth spatial awareness, and this comes at a certain expense of what comes coded in the different algorithms. So to give you an example, I'm going to show one of the photos of the space that was described and the different descriptions that the AI in our app gave to the space and how meaningful they were, but also raised a concern when we were taking this photo in particular and understanding how computer vision and large language models work together to give you a sense of what you're seeing in the picture. The app said,
I like saying this. The app said, is a 25-year-old woman with dark hair looking neutral.
What that does mean, like, for us, right? For everybody, and also spaces that are continuously monitored by these computer vision elements, right? Recordings and bias, which is the central core part of an artificial neuron. Bias is the very way in which we code our neural networks and our deep learning elements and machine learning elements. So the next example is a photo of this curtain. Do you want to go ahead and read the descriptions?
Sure. So we started with the apps which were familiar to our to the participants we had joining us in this product testing session. And the apps that they're familiar using read this as door with a blue curtain in front. And of course, that left a lot of questions about, whether or not the door is open. Is there a handle? Is it a door or a doorway, actually? Does it have a window? Is there a frame, et cetera, et cetera? Things that might be useful for navigating through the space and also getting a better understanding of what the space is about. We tried then let's say, an older version of our own app, and we got this description, so I'm going to read it now. It's, in the bathroom, a blue curtain adorns the window, infusing the space with tranquil hues. A toilet rests on the wooden floor, while a white and chrome chair offers a spot for relaxation. Nearby, a black trash can with a white liner discreetly manages waste. Beyond, a hallway connects to the rest of the building, leading to various destinations.
At this point, we say, we're almost there.
Almost there, yeah. And in the new integration of ChatGPT 4V, the more recent description that we were able to get of this image, much improved, reads as follows. The image shows an indoor room corner with a door at the center, fitted with a window that has a blue-gray curtain tied in the middle. To the left, there is a small white table with various papers and a sanitizer bottle on top, above which is a suspended ceiling with a speaker. A stepladder, trash can, and some informational pamphlets on the wall are also visible. To the right, there's a wall-mounted brochure holder with leaflets. The floor is a dark wood laminate. The setting appears to be a professional office or clinic waiting area.
Thank you, Andrew, and the AI for making that possible. Unbelievable. So we're looking at NAVIGAID as a feature, app, a place where we can come together in technology and collaborate and make more meaningful connections. It's been tremendously inspiring. I cannot extend enough the excitement when we were hearing about this and the reactions from the low vision individuals and blind that have been helping us develop these tools. This raises the opportunities that we're facing, also together with the challenges that we're just discussing. Next challenges for the project is recently we partnered with Meta. Facebook provided us with data sets and an opportunity to extend this to what they call egocentric data-driven design and egocentric data sets, which means that they're capturing data from smart glasses to scan and to make an understanding of the built environment through the ego, through oneself. But also challenging this notion is what we are looking forward to, continue to collaborate into more like an environmental data-driven design and environmental aspect, where it's more about the community, not rather the ego-centric, but it's environmental-centric, environment-centric, community-centric, rather than isolating into each one of us. So if we were with these opportunities and these technologies to ask if you could speak to your house, what would you ask? How can a smart home can assist you? Ultimately, what AI is doing for us at this stage is helping us break down very complex problems into reachable outcomes and milestones to solve jobs, to assist us. So AI is dreaming down the complexity of so many of our tasks, and we are starting to see the impact in many of the say disciplines and work together, all together. I was just recently reading from McKinsey that July 2023, 25% of all our work hours are related to language models. So there's this, every single work measured, every single time there's a job and there's an added value to it. There's language processing involved, language involved. AI has like a strong bite on that, or a strong impact. So the question then remains how to focus that on creating more inclusive communities, on creating more accessible spaces, on making that meaningful for bettering our societies. So NAVIGAID tries to be, approach towards that goal. So with that being the end of our presentation, I wanted to share a quick demo of what we're talking about, more with a hands-on experience. Let's see what the computer thinks about all of us right now. So here I have the app, and we're going to test this live. Maybe it works. Rashid, let's cross fingers. So now I'm taking a photo of the space. Sorry, all right, thank you. And then I will ask, what are the right questions to ask a computer to tell us about this environment? Can you tell me what's in the scene? And then I can ask for a medium or a larger or a smaller description depending on my preference. This is the description feature, not the navigation feature. And now it's calculating.
The image shows a group of people seated in rows, facing the camera in an indoor setting with large windows and a high ceiling. A striking orange staircase creates a focal point in the background. The attendees are dressed casually, and the environment suggests a public space, possibly within a modern building, such as a university, library, or conference center. The seating arrangement and open space hint at a gathering for a lecture, presentation, or informal meeting. Natural light fills the room, and the architectural design adds.
Thank you.
Thank you so much. Are there questions in the room? And there's one online as well. Let me get this one, and then I'll get to the one online.
Thanks so much for the presentation. I found it really interesting. One of the things that I really love that you mentioned right off the bat when it comes to solving problems with AI is that, like, rule number one, the outcome should be something that is predictable. I think that something that maybe gets lost in the kind of sea of all the information that people see around this is that it doesn't have to be something that is intuitive, though. So something that is not intuitive but predictable, I think, is really relevant when it comes to people who have different perceptual sets and abilities, because we have all these biases and assumptions around like what we experience and what information is relevant to us. So I was just curious, are there any sort of like surprises or unintuitive things that you've discovered in either testing with users or just the research that you've done that have really informed how you maybe have these 3 different modalities in your product, or any other sort of feature that's like helped them in a way that surprised you at least?
Thank you for your question. I'd like to address it, maybe extending the question and also narrowing it down, if that's okay with all. Along the way, we have discovered that, let's look at the stats, right, that we were reviewing. There are so many challenges that communities such as the blind are facing every day, and low vision individuals. So we've discovered, for example, that the application has been, or is desired that maybe it helps them build games and play games rather than navigate a space. Also, we've discovered the challenges of such a complex space that is quite not as predictable as what one like, or maybe there's not enough data yet about identifying hazards. So we're discovering along the way maybe some applications that can be low-hanging fruits versus some can be new opportunities, game design, edutainment, education. The demand for having this, for example, voice be a kid's voice for kids that have difficulty navigating space rather than this robotic-ish, which is already a good job. but these new opportunities that happen around the problem, and they all are centered in this problem, right? Do we have enough data? Is the data meaningful? And if it's a determinate problem, not one indeterminate. Is it not a chaotic system, but a complex system that can be broken down into elements that can be predictable? So no stochastic system would work. When we work with elements that can be predicted, we have very random results. So this brings also the issue of safety risk at using these apps, allowing them to operate our decisions maybe independently. Now I'm extending the question to what happens is, in general, when machines take a certain work and they operate automatically. So to give you an example that it's outside of the NAVIGAID, when McKinsey was testing this, they reviewed that, for example, doctors could have a 7% error when detecting cancer in their lungs. And when they trained the AI recently, they reached a 5%, no, wait a second, the other way around. 5% doctors or 3% doctors, 7% the AI. So it was very good, but still the most interesting outcome was when they were working together, put a 0.3%. This is a great opportunity that we have to collaborate meaningfully with the machines without removing the communities, the voices, the individuals from the loop.
Great. Wait a minute. We've got a question here.
So concerning the question, I think some of the surprising facts we realize is that we tried to use the state-of-the-art computer vision techniques in order to automatically detect this path, stairs, all the things that you can recognize. And it turns out that we saw lots of techniques are not that realistic or like easy to apply. And then they may bring lots of like errors, and that's also kind of not that successful experience motivated us to further like try to establish the collaboration, more close collaboration between the people of architecture and the people of computer science, so that we can do this co-design of the software app together with the building environment, so that the building environment may provide more signals or more relevant information to facilitate the detection or this reasoning of the space by the computing techniques. Thank you for the question.
Thank you. So we've got a question online. How do you set up a project like this in architecture? This is a disciplinary question. How do you do the human subject protocols, and how do you recruit for potential test users?
I think we're, we're still figuring out exactly how it is that we will be recruiting test users. But one of the exciting possibilities that we have, that we're planning for, is to create, let's say, a relationship between the functionality of our software and then prepared spaces on campus, so that participants of our annual Blind Design Workshop, which takes place every spring, the School of Architecture's Blind Design Workshop, will be happening in April. We'll have 12 to 15 young learners participating in the world's only career exploration experience in architecture for vision impairment, for individuals with vision impairment. And we'll be excited to share those opportunities to interact with the app and then also use the app to interact with space then. But in a more structured way, we're still figuring that out, exactly how it is we include human subjects in the training.
I'd like to add a couple of comments to that, if we have enough time. So problems are not departmental, right? Problems don't decide. I sit in a department, and then they wait for being solved. This is probably, I don't know, a scholarly tradition that has been inherited. And now we can look at problems cross-departmental, of course, in their very nature. So every time we look at the problem, we look at it from a different perspective in a conversation. We have these different inputs that shape a part of the solution. So in terms of the first part of your question about architects working together with computer scientists, and this be an effort from, say, sitting on our department, ultimately it's about the problem, right, and how we approach it with an interdisciplinary work. While on the other end, as we're working with human subject research, we have phenomenal support from the Institutional Review Board here at Virginia Tech to help us navigate and create good practices when doing research with human subjects. So just to highlight an opportunity and a challenge, we've realized about the importance of organizing our research with prioritizing the validity of the outcomes. Say, for example, if you do an interview prior to a survey, how much will you influence the survey results? Just that, like just as simple as what is our place in making sure that the right research ethics, guardrails, the right practices are in place. So we do not want to influence the results by, say, intervening in a conversation. That in that end, it would make more sense. Let's do the survey first, and then let's do the focus groups. Otherwise, we would be, say, inferring several solutions. So those are challenges that we're continuing to learn with the support of the university.
Great, thank you. We have time for one more question.
I was wondering about the use of the app on the phone screen for people with vision impairment. I'm wondering if there's any kind of barriers to actually using a visually based app. And it also made me think about the use of a photo as a medium, because you can imagine we're all sort of stationary here, but spaces are not always static, and especially if you're moving through them, spaces can change. So I was just curious about the use of sort of photographic static medium, the visual app, and sort of could it be video based at some point? How do vision impaired people use like a visually based screen app? Just curious. Would you like to?
Yeah, sure. So we haven't developed this yet in our own app, but typically you would use a screen reader. That you basically learn how to dialogue with. In the iPhone you use 3 fingers to swipe. With an Android you use 2. And as you scroll over options, it reads aloud what the options are for selecting on the phone. So that would be the way that you navigate. For example, our own app would be to use a kind of familiar screen reader that's familiar to individuals with vision impairment. In other words, it delivers all the instructions by voice through the phone. For now, the way that people with vision impairment use apps like Seeing AI or our own app would be to take a photo of a particular scene and then get instructions back. So I think even with a video, it would be taking an image from the video. No? Yep. Yeah.
At that point, it's about the computational capacity and making this as accessible as possible. So one can take, say, faster cell phones. I took more time opening my cell phone than actually processing the photo. So it's also about the access to the tools, which raises a concern and a challenge, right? The differences between this app, its meaningful impact, considering Global South and access to technology versus what does it mean in our context, safer spaces where you can actually travel with a phone like that or with cameras on your headsets. All of these questions remain somewhat open, but I mean, computational power is increasing. Capacity to discretize videos into frames that you can make a somewhat meaningful understanding of. The technology is there, so they're matching, but it's also about how do you match this with the constraints of making this as accessible as possible.
We had an interesting question for the blind participants we worked with just the other day, and it was, what would be your preferred latency period between when you send a photo in and when you get an answer back? And the response was quite nice. It was, we're willing to wait longer if the information is better. In the same way, and this was the example given to us, that you don't mind waiting for your computer to boot up because it's going to be great, once it's on.
We are out of time. I know we've got some more questions in the room, and I'm really excited that we have such great conversation. Please feel free to continue chatting and stay in the room, but we're going to close down. And thank you all so much for being here today, and the rest of the team as well. And I hope you all have a fabulous weekend. Thanks, y'all.